Hey everyone, welcome to Virtual Build North America. The panel session titled From Basics to Next Level, How to Build or Refine Reality Capture Initiatives. My name is Alice Leung and I'm the Sponsorships Manager with DBEI, and in my day job, I am an investor at Brick and Mortar Ventures. I've been following the reality capture space for a really long time, so I'm excited to introduce to you Zach Goepel, Director of Marketing and Global Partnerships at Avvir.
Thanks so much, Alice. Welcome, everyone. Thanks for joining us today. We're really excited to have an informative panel where we hope to educate everyone out there who is either looking to build a reality capture program or who has one in place and looking to elevate its capabilities. Have a really expert panel today, which we will informally ask some questions among them for their knowledge and expertise and to share their learnings on some takeaways for building and increasing the power of your reality capture initiatives. The three panelists that we are fortunate enough to have with us today, starting with McKenzie Lewis from McCarthy. McKenzie is Manager of Emerging Technology at McCarthy. His background specializes in the review, selection, and implementation of a dozen different construction technologies for field and innovation teams at McCarthy. He spent over 10 years at McCarthy in roles ranging from PE to VDC managers to application specialist. And in his current role, he manages corporate technology. Shaun Lewis is our second panelist. He comes from AECOM and has a diverse background of AEC experience, including civil engineering, surveying, and construction. Shaun's developed a reality capture program at two of the larger general contracting firms in the DC metro area, and currently is the BIM VDC Digital Practice and Technology Manager at AECOM. He oversees a group of passionate technology professionals revolutionizing the way assets are captured, documented, and delivered. One of the primary focuses of that digital practice group is transforming lasers scanning data into data-rich models. Shaun is one of the earlier adopters of reality capture and is widely considered an industry expert. He's going to be an invaluable asset to us today. And last but not least, we bring on screen Tim Conroy, who is from DPR, bringing a background similar to a hybrid of our two other experts. Tim brings 10 years of experience at DPR in roles ranging from BIM engineer, where he lived and breathed the model, even wrote some programs via low-level code, to innovation analyst roles evaluating tech, to reality capture manager, where he worked firsthand with this technology. And he's now in a current role as a technology group leader, bringing a wealth of experience on what to do and what not to do when it comes to delivering value with technology in the AEC market. So I'm really excited to have this group. As I said, I think it's going to be a great opportunity to glean some learnings and value. And with that, I'd really like to just get right into it. I will kick off quickly with a live poll as I initiate the first question here, just to get a general idea of the level of expertise that our audience has currently with reality capture. Just triple checking with the organizers that it's up on screen. Looks like it should be from my side. And I'm going to let it roll here for a couple seconds while I introduce the first question, which is, as indicated by the title, we really want to hopefully provide insight and value to those of you that might be interested in creating a reality capture program, as well as those that have some reality capture and analysis capabilities. And so what I'd like to start off with today, asking the panel, and I'll shoot it over to McKenzie to kick it off, is what technology, what approaches, what are the low-hanging fruits that one should consider when thinking about initiating or building a reality capture program? What are the low barrier to entries maybe that have still some big impacts for the industry when it comes to reality capture?
Yeah, thanks, Zach. Low-hanging fruit, I think on this topic, there's a lot of opportunity now for low-hanging fruit. The technology's gotten cheaper, and I would suggest focusing on 360 photo technology. There's cameras now. You just buy one camera, you can get all 360 degrees, and you don't have to stitch the photos together. And you can get those for under $500 today. So you can buy one of those cameras, walk it through your building during critical times of the project, and take those milestone photos where you're capturing everything in that room. Those are, invaluable pieces of documentation, and you can do it in a very fast way. Before we had 360 cameras, it was pretty standard to go take pictures of every single wall. So just right there with the hardware going to 360, you're already saving a lot of time getting the same photos. So that's a low-hanging fruit. I would suggest getting started there, and maybe I'll leave a few others for the other panelists.
Hey McKenzie, why did you get into the 360 photos? Why did you guys first kind of really start doing that?
Yeah, so a couple reasons. We were already taking in-wall photos, and it was just so much time. We had to download the photos, upload the photos, then we'd pin them onto the drawings. That was one thing. And then also we wanted to figure out ways we could have our partners experience what it's like on the job site. And that's where 360 videos kind of came in, and we did some really cool stuff at Loma Linda with the children out there, doing 360 videos on site and then putting them in the VR goggles for the kids so they could kind of feel what it's like on site.
Pretty cool.
Yeah, that's a unique application. That's actually how you stumbled upon sort of where you could use the value within on the job site, right? Is through that experience, which I think is pretty novel. Shaun, from being one of the people that has been hands-on with the technology for a decade, McKenzie lists a few, the piece of hardware that's typically the entry point, which are these 360 cameras and videos. Some people are even taking those now just for standard site documentation and things. What are some of the values and takeaways if you do have that data set on hand as it relates to, reality capture and analysis? Maybe what else what are some of the other applications of that data that are meaningful for the industry?
Yeah. So again, speaking about the low-hanging fruit of the 360 cameras, and whenever I try to implement anything, it's always, okay, what's one of the problems that we're trying to solve? And one of the problems a few years back was just documenting construction progress, what actually has been done. So that was why we got into 360 cameras. Now what we're seeing is you're not just documenting things in place. Now you're starting to get to the point where some of the software is starting to either you can add data to it, and then you can export out into an Excel sheet or whatever it may be. Let's say it is Excel. And now you can work with that data in other platforms, say Power BI or whatever it may be. But the 360 cameras now are becoming, they're almost like how models became BIM. 360 cameras now, some of that information is going to be inside of that software instead of it just being a 360 photo that you look around, which I think is really neat. And that's where it's kind of going to the next level. But again, it's always about what's the problem you're trying to solve. And initially for us, the low-hanging fruit was just documenting construction progress. Now we're starting to add things to it that says, okay, this is when it was done. This is why it was done. Here's some information about it. This was the contractor that installed it. All that information is now starting to get inside of it as well.
And one of the ways you're sort of connecting the thread there is through the model. Is that right?
Yeah, obviously the model is becoming, I think, it's not quite the contract document yet, but I mean, the model is what everyone's building essentially, as long as you keep it up to date, and that's where everything is going. So if you're not heading down that path, you're kind of going to get left behind.
And Tim, I think there was a tipping point even for you, right? In talking to you in the past, maybe almost a decade ago as well, where I think your team was actually using them for progress photos, as Shaun mentioned, and you really found a new avenue for that data stream. Is that right?
Yeah. So our use cases started probably back in like a little before 2012, but in a very similar vein. We were taking thousands of photos with iPhones, with point and shoot cameras, if those still exist today. Basically anything that could capture an image, and then to be like, okay, let's throw it on Box, let's throw it in on Apple, and just thousands of photos. And it was a similar document progress. What can we show the owner to prove that we did build something? And so it was mainly done to just in case. You never know what you're going to need the data for. So it was, well, just go out and take pictures, which then resulted in thousands and thousands of photos. If we ever had to find them, it meant someone, unfortunately, had to sift through all those photos looking for a needle in a haystack. And to us, or to me, really, the low-hanging fruit piece of it is, what can we do that is both inexpensive but also widely available to as many users as possible? And one of the things that we had some early experience with laser scanning, but it was mostly third party. Back then it was more expensive. It was harder to capture. It was harder to process, and so we usually used third party vendors to do it. And the tipping point for us was when we started using UAVs or drones. The fact that you could capture a different vantage point. Typically speaking, photos taken on your phone are between 4 and 6 feet off the ground. Now we can fly 100 feet, 200 feet, whatever the FAA allows us to go up to, and you can get a very different perspective. And so for us, I would say, yes, we had experience with laser scanning early on, but the kind of the catalyst to some of this reality capture or visual documentation of our projects was via the air and through drones.
That's an interesting and great point. You briefly touched on a potential pitfall, and I want to table the pitfalls maybe until after we get beyond the basics. So as I think is expected, right? Some of these more inexpensive pieces of hardware like the 360 photo and video cameras, and oftentimes we've seen drone technology really decrease in price while increase in its capabilities in the last 5 years. That sort of is your typical tool set for getting your feet wet. And through that, to your point, right, depending on where you leverage that data, if it's in your BIM or you're leveraging aerial versus just on-site structural photos, you can glean a lot of different use cases and value out of that. If you want to take the next step, and or if you already have capabilities outside of 360 imagery, what does that look like? What is sort of the beginning of the advanced area of the discipline of reality capture and analysis? Shaun, I'm going to throw it over to you, being someone who's so hands-on with the tech, to kick us off on sort of dabbling in the advanced realm of this technology.
Yes. I think we're starting a natural progression that Tim mentioned, where we went from 360 cameras to now drones, which just keeps going down the line of more advanced. And then you get into the LiDAR, the laser scanning. And it's one thing to just laser scan, because that's essentially, so many people are laser scanning now. But when you want to tip into the advanced side, it's what you're doing with it. Now, we also already just mentioned about BIM. BIM is the key when it comes to what we're building and what we're comparing it to. LiDAR is the facts, the reality. That's what reality capture is. It's the reality of what's happening. Now, when you start comparing that to BIM, now you're onto something. And that's where the next step is. And that's how the ROI is right there. When you know where things are exactly located within a half inch, let's say, everything on an entire floor, everything in an entire building, when it was. And then if you can project the progress based on what's installed, what's not installed, now you're reaching that kind of holy grail of cost, money, schedule, all that in one kind of shot. So that's the advantage, is comparing scan data to BIM.
And ultimately, I heard you say half inch, right? Tim, I want to send it to you, because I know that accuracy and precision and control, right, is really critical to getting the ROI out of the advanced discipline, because it's easy, right, to buy all the shiny objects, to get all the data, and a couple missteps in the setup process can yield unfortunate results.
Let me get some popcorn real quick while Tim starts.
I'll try not to grandstand too much or jump on my soapbox, but yeah, that is definitely a topic that is very near and dear to my heart. Real quick on the before I jump into the geolocation, accuracy, precision stuff, the one thing that I think we need to just go back to what Shaun said was, to go from the beginner level to the intermediate or the advanced level, you really need to define a problem statement. If you just go out and buy a scanner and say, okay, now how do I use it? You may find out, you may figure it out. You're going to probably spend a lot more time spinning your wheels, wondering, okay, did I just make a mistake? This was a really big, expensive ticket, big ticket item. What am I doing with it now? So always start with, what am I trying to solve? And so going back to then the question that was asked of me.
Well, actually, real quick, Tim, before you dive into it, I mean, I think there's a unique application of edge cases, which, there's situations where there's a problem, and that's the why, and you might be able to articulate a really intelligent solution for how reality capture might solve that edge case. But maybe before you go into some of the more details of the accuracy, what are some of the more standard and stock sort of workflows and takeaways and value that you get out of just upgrading, your procedure, your hardware? Like, what are some of the standard offerings that LiDAR provides that maybe the 360 photo and video don't?
It gets you a higher fidelity model or data set of information. So like if you go in and you're doing existing conditions documentation, that's probably one of the most entry level, at least for me in my experience. We started doing existing conditions documentation. The very first use case that I had the pleasure of being a part of was a good old waffle slab in DC. You can't go through those spines. You have to core through the pan, and so we had to know where they were, and so you can't coordinate a model and make sure everything is in the right spot if you don't know where those waffle slabs are. And so to me, the existing conditions documentation is probably that lowest hanging fruit of scanning. So yeah, that's probably the most standard one I can think of.
Because a photo can pretty simply tell you that the waffle slab's there or not, right? But it can't tell you where exactly it is. Right?
Yeah,
so
it can tell you have a waffle slab, but it can't tell you where the pans are versus the spines are. And so if you're spending all this time and money to coordinate, I mean, let's look at the coordination process. There's how many players involved in that from the design team. Sometimes you have the owner or the client on the call. You've got all the trade partners. You've got, 10, 15, 20, maybe 50 people on some of the larger jobs. It's a lot of money sitting on those calls. And if you're coordinating something, you don't exactly know what your ground truth is or what's actually out there. What are you coordinating to? It may be a giant waste.
What I love about that, Tim, and we talked about this before, is that was one of the firms I was at before. The reason why they bought a laser scanner was because of a waffle deck. Because of that waffle slab, for coordination, you need to know, as mentioned, where the pans are and where the spines are. And that job alone gave us the ROI for the laser scanner on one job that had waffle slabs.
Yeah, but to do that, I mean, let's bring this right back around to my grandstanding. I can't miss the opportunity to talk about control real quick. But I mean, the biggest challenge with this data is aligning it to what? Do you just have it floating in space? Do you align your model to the data? Do you align your data to the model? Do you align them to each other and then to the Earth, to the actual physical location of the space? And so it comes down to trying to figure out, well, what is that use case? What is the needed level of accuracy? And what do I intend on doing with this data? And so if you're just going to look at it for a coordination reason, you take your data set, you align it to the model. You can do best fit. You don't need control. You don't need a surveyor out there. I wouldn't suggest that you always ignore that. You can best fit the model or the point cloud for certain use cases. But then if you're trying to build from that model, like Shaun alluded to earlier, the holy grail is to take that model that we're spending so much time coordinating, take it out to the field and actually build from it. To do that, now you have to tie into something that is real. You can't just go, I hate to say it, but like the Architect 00 that's somewhere on a grid intersection somewhere, that may not be good enough if you can't take that information out to the field and now locate those sleeves, those embeds, everything else that you need to build per the model. So you do need control. You do need to know the accuracy, the precision of the instrument. You can't push your instrument beyond what it's capable of doing. You got to keep in mind compounding error. Survey grade control is still plus or minus a quarter inch. So if you're trying to coordinate something tighter than a quarter inch, you got to remember you can only be as accurate as the previous system allows you to be. And so if your control on site, grid lines, chalk lines, control points, whatever they are, if they're only a quarter inch plus or minus, you can't coordinate something tighter than that. You can place the objects tighter than that because we can get to a 16th or even tighter in Revit and other software. but you can't lay it out any tighter than that. So you got to keep those things in mind, and the concept of compounding error. With that, I will get off my soapbox. For now, I think we may come back to in the pitfalls part of it, but yeah, we just got to keep in mind accuracy is different than precision, and the alignment of the model to the real world coordinates.
So that's huge, because like you said, especially when you talk about compounding error, because if you don't appreciate the error in its original form and source, then by the time you notice it, it could be totally out of whack, right? So knowing
everything has error.
Yep, knowing what that error is and controlling for it, at least as it relates to expectations, right, is critical. Before we get to the pitfalls, though, and we'll kind of sum up some of the challenges and pitfalls, as a whole across the basic sort of approach as well as the advanced one. McKenzie, from McCarthy's perspective and in your history, once you have sort of acquired the capabilities of this advanced workflow and this laser scanning capabilities, what are some of the other, if any, workflows and deliverables that you might be able to produce out of it? I mean, I know as-built is digital twins is a huge topic right now, QA/QC. What else do you find that this advanced sort of data enables?
Yeah, so I think one of the most important things to remember is, like, talking about accuracy is answering the question before you get started: how accurate do we need to be with this reality capture? And if it's less than a half an inch or quarter inch, photos are not going to give you that level of trust. So understanding your level of accuracy, and then figuring out, okay, what can we do with the tools we have, and how can we get more advanced? So really, I think this whole kind of started because 3D models became such, they just continue to become more and more important, and eventually will become the contract document. But we're going from this 2D world to this 3D world in design, and we need to validate that world is being built accurately, and the only way to do that is with the 3D model and some reality capture that's 3D. So how do we compare the two? Finding isolated areas of the building can be a good way to start, where you're not doing kind of the whole building, you're kind of in a localized space. One of the first laser scans I ever saw, we were building a bridge from our building to an existing structure. So that helped us get the whole side of that existing structure scanned. And then again, you got to find a real world coordinate that you trust, a few of them, so you can tie the scan to that, then compare to the model. And depending on where those control points are, you can have error kind of happening the further out you get from those. So there's a lot to think about. One of the coolest, just kind of going back to some low-hanging fruit use cases, was when I started realizing I could send my drone up. The drone could take 6 or 12 photos, and then we stitched those together. And now we have you're building a hotel or something, and the owner wants to see what's the view going to be on the 15th floor. You can really send that drone up and get a really cool view for them to, hey, this is what the suites are going to look like in this hotel, or what the best views are. And then to go more advanced, like they're saying, I mean, you got to have a model that you're planning on doing something with.
I think you brought up something good there, McKenzie. It's, we're talking a lot about accuracy and precision and comparing laser scanning to BIM, but sometimes a great use case that makes an owner happy, which is essentially what all of our jobs are, is just sending a drone up to the imaginary 15th floor of a hotel and showing what the view would look like. Like that's a lot of value for something very simple. So you can't forget about some of these little side things, marketing type images, those types of stuff when building the reality capture programs. That also helps with helps selling it to some of the executives. So you can't forget about those little things too.
It's not just marketing either, though. I mean, there is a lot of marketing value in those photos, but we got to remember that we spend our days looking at models, looking at plans. We can visualize things because we are builders. But if you're talking to a surgeon or a realtor, they may not be as comfortable in a set of drawings or in a model. And so making it real for them. It's funny you guys bring up the drone on the 15th floor. We've got projects out in Texas that did that exact same thing, and they threw it into one of those headsets behind you, Shaun, so that the occupant could see what is my view, and they could look around, they could kind of feel, and so it makes it real. And that's, we talk about the reality capture, but it's also taking that, flipping it on its head, and saying how do we put someone into an environment that makes it feel real and they can experience it.
What I think is particularly interesting about this little side topic is, to Shaun's point, in many cases, these are like basic features within even like the basic discipline, right? And oftentimes they're included and maybe not super relevant to the coordination team or to the construction team, but very much so to the owner or for bid packages or for whatever. And what I hear is interesting about this from like a vendor and third party perspective is how, ultimately you only need a couple of these little wins to pay for the technology to get the owner excited, to then leverage it for the super user, strengths that it might have for your internal teams, right? Whereas that might be difficult to pitch and to sell, to an owner if it's really just helping your coordination and to minimize, clashes. But being able to weave in the marketing element and this visualization element and almost effectively sort of sell and pay for the technology to provide value to both user groups is kind of interesting thing I'm hearing here.
A golden rule that I've learned and try to tell other people is a whole bunch of small wins is going to end up equaling a big win. So if you get some of those small wins, that's going to lead to something bigger.
More often, yeah, more so than one big win, right? Well, with that, I think it's really easy to talk about all the positives and all the advantages to technology. I think one of the bigger dangers of technology in general, but I feel like to a large extent where the construction industry's gotten itself is, not appreciating the limitations and not managing those expectations, and sometimes getting burned by the reality of those. So, maybe I'll start with McKenzie, if you don't mind, being the person who I think is probably closest to the implementation and adoption and execution of these platforms and technologies. What are some of the pitfalls that you see with either or both of the disciplines that you'd want to make sure that somebody either starting their own program or are looking to elevate theirs, make sure to consider?
Yeah, some pitfalls on the low-hanging fruit. I think it's just figuring out what your deliverable is going to look like, because there are softwares that you can kind of pair up with that 360 camera to make it really easy to get the photos on the drawings in a nice, easy way where it's just kind of one step. You don't need to download, then upload, and put pins all over. So there's that. And then I think one of the challenges that gets underestimated about the laser scanning is how long it takes to process the data and what type of computing power you need. We tried to do scanning of wet concrete and get like, maps of where the flatness is or deviating from what we wanted. And it's just so hard to get that turned around while the concrete's still wet, And so understanding that challenge and making sure that you've done one of these, how fast it'll take or how long it'll take. And then figuring out what are you going to do with it and how do you want it to look at the end before you get started can help.
No, that's huge. Just starting with the why, I keep hearing, right? Tim, what about in your experience? What have you seen as things you want to make sure to avoid or manage in the process of introducing some of these technologies?
Yeah, so one of the things I would strongly suggest is, sometimes we get into this, we get a little excited, and so it's, hey, there's this new thing, it's meant for this somewhat routine activity, and we try to apply it to these really specific, really niche applications, and we start to get a little caught off guard, where it's like, okay, that didn't quite work out like I expected it to. And so one of the things that I would suggest to to Mackenzie's point, plan it out. Do some dry runs. Maybe try it out where you're not like in the heat of the moment, because there's nothing worse than being the guy behind that instrument trying to turn it around where you've got maybe 20 finishers like looking at you saying, okay, where's my high point? Where's my low point? What do I got to work on? Concrete's hardening. It's not going to stop. So you got to plan it out, maybe do some dry runs. And my big suggestion for anything that we try new is do it multiple times. Try to show repeatability, because if you're concerned about the quality of the data, scan the same thing twice. Do it from 2 different spots. Does the data look the same from both setups? Is it repeatable? Because you may find that, hey, you did it once and it worked, and the second time you do it, it didn't work. And so if you do it a couple times, you start to build that confidence because it's repeatable.
That's a great point. I mean, a single success story doesn't mean that the larger implementation will be successful. Shaun, are these files small and easy to share?
Yeah, so it's those are not, and no, it is not easy. If we talk like Pitfalls, I think one on the lowest hanging for 360 cameras, it's managing expectations. 360 cameras, when you're just walking through a site, let's say a lot of people like having the camera attached to their hard hat, it's going to be blurry photos. So as long as you just manage that expectation, you're good. But that is one of the pitfalls, is people sell this as like this great thing, and owners come in, they're like, why are my photos so blurry? So that's just something to be aware of. On the drone side, you have to be prepared for a drone to crash. 100, I've been told by drone insurance people, 100% of drone programs, 100% after having a program for, I don't know what the length of time is, but they have a crash. So be prepared for that. Know the safety managers, know how your organization works within safety, but be prepared for a drone to crash. And then with laser scanning, you just hit on file sizes, and sharing it is hard. The file sizes are so huge. So another thing is, people might buy a scanner, they'll buy software, but they don't buy a proper computer. Thankfully, a lot of people in our world, as far as VDC construction technology, at least have a decent computer, but the people you're sharing with might not. So when you go to share it from the VDC side, now you're sharing it with a project team. They probably don't have the same spec computer that you do. So you got to really decimate down and unify your point clouds, so it's just smaller sizes. Sharing wise, that's getting there. We still to this day sometimes ship hard drives. I hate it. It irks at me, but sometimes it's the best way, is literally sending someone a hard drive if the data is just too large. BIM 360, we've been doing a lot, but that still has limitations. Once you hit like 40, 50 gigs, it really kind of slows things down a lot. But smaller ones, that works really well to share data. There's some other programs out there, but then you end up being kind of locked into someone's software. So, but yeah, sharing the data is an absolute pitfall, but you got to find what works in your organization. But I find decimating down point clouds helps a lot.
Yeah, just to pile on real quick. So one thing that I think, again, we all like to say, well, if I capture the whole sphere, maybe I can get more value out of it. Or maybe if I crank up the quality, a point per millimeter, we're like, oh, let's just capture more data. Stay focused on what you're trying to test. Sometimes, there's scanners out there that allow you to do a low res scan of the whole sphere, so you get, some context, and then it'll allow you to do a detailed scan of exactly what you're looking for. Doing that kind of stuff will greatly help. You may be nervous at first, where it's like, well, what if I need just off to the side? Well, then you go out and scan again. But it helps you to keep that data set small. So like I hear all the time about these 50, 60, 100 gig data sets. We've done probably close to 5,000 scans on this campus that I'm on right now. I would say our average scan size, 100 megs tops, because we keep it very hyper focused on what we're reviewing. And so if we're doing site utility scanning, just scan what you need to see. I mean, you may be tempted to scan the rest. You can do it at a lower resolution. And the other thing that I kind of hear it echoing through some of these responses, use the right tool for the job. Just because you have a laser scanner doesn't mean you're replacing photos. Just because you have a laser scanner doesn't mean you need to get rid of your other stuff. Personally, I've spent a lot of time with a robotic total station, and the number of times that I get called out to set control points so that they can lay something out, when guys, a tape measure still works. If you've got framing down, don't forget the old school method. There is a time and a place. There are times when tape measures will beat out a robot in speed and accuracy because I have to set up. You can pull a tape. The setup of a tape measure is pull it out.
Did you see that robot that hangs drywall? He moves so fast.
True. Okay, there's exceptions to everything.
So
but
he moves
I just
so
still say
fast.
use the right tool for the job, not just the new and exciting one.
A great point. We only have a few minutes, unfortunately. I feel like this is going to be a 4-hour conversation. And I do think we have a question or two. So leaving maybe 60 seconds for a couple of these questions. I really want to close with some of the thoughts on a combination, and maybe we can only hit on one at a time, but how do you improve, what are the opportunities to really take the next step with the existing capabilities that we all have, technology, hardware, software in this realm, and or what are you really excited about for 5 years from now, 7 years from now, 10 years from now? McKenzie, let's start with you, and if you can, try to keep it like 60 seconds.
Yeah, I would say the best way to get a little more advanced is find a way where you can compare the model to a 360 photo, but they don't necessarily need to be like tied to each other. That you can just put the photos next to each other, sync them up, and then you look and you've seen your photo and the model view. And that's kind of a visual way to do comparison that can be pretty effective in a lot of ways. And then, yeah, let's see. What was the second part of your question?
5 years down. What is that exciting sort of on the cusp technology that you're looking forward to seeing?
When we can, I'm excited to see how mobile we can make LiDAR and how easy we can make it. I'm excited to see what these new iPhones might be able to do. And is there a way that, your foreman or somebody in the field could go scan a little area, get it over to an engineer, and validate in a trustworthy way with some cheaper hardware? That's what I'm excited for.
Yeah, I think, and the LiDAR iPhone was one of the questions. So if either of our other panelists are excited about that technology in the future, maybe we could touch on that question too. But Shaun, let's go ahead and hear your thoughts about improving the existing and looking forward.
That's exactly what I was going to hit on, is the iPhone LiDAR, but maybe not in the ways that some people think. I'm excited because it shows where the technology is going into smaller, easier, more people's hands. But I look at it as specific use cases in construction. When you're doing utilities, they get put down and then covered up very fast. A lot of times it's hard to mobilize your laser scanning team if there's not one on site to document where those utilities are. But maybe you can figure out with that iPhone LiDAR, you throw some targets down and you go through there and just do a utility, just one little area. And you just focus on that specific area that's about to get covered up. Now you've documented where that utility is. And you don't have to be that accurate with utility. You don't need an inch with the utility. You just need to know there's a pipe here. And so I think that's just a good specific use case. And every person on the job has an iPhone. So I think it's something that could really democratize the market there. And I think it's a good use case.
And I mean, you're touching back on a lot of the other points, which is use the right tool for the job, right?
Yes.
Doug was the one that asked, is this technology useful today? And based on that answer, it sounds like a resounding yes, if you know what you're using it for, right? And if you have the right expectations set, it can be immediately valuable. So Tim, let's close it off with you before we crack our beers. Yeah.
So I'll just skip right to the exciting, what excites me for the future. To me, it's, I want to stop collecting data. I want to stop reviewing data. I don't want to find the problems. I want systems like Avvir to find the problem based on the data set that something like Spot collected. I want to use our brain power to solve problems, not find problems. So that's what excites me about the future, is just getting to where we can add the most value with the least amount of capital.
And I think you actually, I've had the pleasure of hearing you speak on a couple other panels. And if we're really looking at that 5 to 10 year, I mean, I think I've heard you talk in the past, not only like today we're at the, use this technology to find the problems so you can solve them. But I think I remember you even getting excited about leverage AI and deep learning to help inform how to fix these problems in 5 years, maybe, right? Which I think is a really unique concept. So with that, we were told explicitly by the organizers that Built is a fun networking, engaging, drink happy group of people. And being the closing session, we were asked to come with refreshments. So with that, I'll say a big cheers to everyone out there, especially to my 3 panelists here.
Cheers.
And,
hey, remember, everyone that's if you're not on the U.S. East Coast, it's 5 o'clock somewhere, and it just happens to be on the U.S. East Coast. So
It's technically 5:30 somewhere, depending on your time zone. It may be 5 somewhere because of the half hour time zones.
yes, well, whatever.
Good correction.
Thank you, Shaun. Thank you, Tim. Thank you, McKenzie. Thanks to the organizers at Built and to each of you in the audience. And we look forward to having the opportunity to present to you in the future.
Thank you, everyone.
Let's go push the boundaries.
Yep.
I like it.